Okay, so far we have obtained the witness file. Now we need to create proving and verifying keys using the key generator here. So we go back to our programming environment to create the necessary keys. For proving system, we can use Planck, fflank, and growth 16. We discussed these methods in course 1, and you should be familiar with their differences. In this Fibonacci example, I will use Planck, which consists of one key generation phase. This phase is circuit independent. So first, I create a directory for powers of tau. Go to the directory and try to initialize a fresh powers of tau file using a snug.js command. Snug.js powers of tau new bn128 12, and then I specify the output file phase 1 pod 2 pod 12 00 p tau. The tau power ceremony is designed to accommodate up to 4096 constraints, means 2 power 12, as you see here. Remember, for this setting, the upper limit is 28. It means that the maximum number that I can put instead of this 12 is 28, which led me to create 268 million constraints using snug.js. But in these examples, we do not need such a huge number of constraints. Therefore, I chose only 12. The next command is the contribute command. Using this command, we generate a new contribution in the p-tau file. For this step, you will be prompted to input a random text, which gives us opportunity to add another layer of entropy. Also, the name argument here serves as a label for reference and appears during the file verification step. Moreover, -e parameter enables the inclusion of random text directly in the command, allowing for a non-interactive contribution process. We can add another layer of the contribution using the second command. Or we can introduce a third layer of contribution utilizing third-party software. I will add all these commands to our GitHub code, and later you can just copy and use the commands. Finally, to enhance randomness, we implement a random beacon in our p-tau file using this command. And then we finalize our p-tau file using this command. This preparation command performs encrypted calculation of the Lagrange polynomials at tau, alpha tau, and beta tau. We discussed these concepts in course 1. Finally, we verify our generated tau values. As you can see, snug.js shows us that the powers of tau are okay. It's very important to know that you do not need to do these steps on your own computer. You can simply download the bn128 p-tau files with 54 contributions and a beacon from this link from the internet. Therefore, you just need to verify your powers of tau using the last command that I showed you and check whether the downloaded file is valid or not. Okay, so far we have created the powers of tau keys and verified the generated values.